Yes, this is example number 14, lecture 4.01, the first lecture of P block element stage 1, and this is slide number 32, example number 14. Okay, coming to the question, which of the following orders are incorrect according to the indicated property? First one is, N2O, NO, the increasing order of oxidation number of nitrogen, and second order is acidic strength, third order is also acidic strength, and the fourth order is bond angle. So we'll see a couple of this one increasing order one by one we'll discuss so that it's completely clear and you'll know the correct answer what it is. So option number one is example number 14. First one, N2O less than NO less than N2O3 less than N2O4 less than N25. This is oxidation state plus 1. This is oxidation state plus 2. This is going to be plus 3. This is going to be plus 4. And this is going to be plus 5. Correct. Therefore, the order given is correct. So this is the increasing order of oxidation number. In fact, this is the increasing order of acidic strength of these oxides. This is a very important point. Okay. Option 2. What is given is P4O6, N2O3, AS4O6 greater than Sp4O6. They say that this is the acidic strength of oxides. I'm sorry to say this option is wrong because basically, Sb4O6 antimony 3 oxide is having less acidic strength than arsenous oxide because of the fact that they're amphoteric in nature. So both these are amphoteric in nature, but still this is a small, minute difference in the acidic strengths, which is due to the size of the atom. Okay, next. So these are amphoteric. Both are amphoteric. Next, coming to the next one is P4O6. P4O6. Then comes N2O3. Therefore, this is highly acidic. Highly acidic. And P4O6 is a little bit less acidic than N2O3. Okay, because of the fact that when they dissolve in water, when they hydrolyzed, they give the corresponding acids, and the corresponding acids have a greater strength compared to the next molecule. So always oxide of nonmetal is highly acidic. Generally. Okay. When you come to D block elements, this word what I told will fail for some oxides. So, and nitrogen is having a very small size compared to phosphorus. Therefore, the way it's going to produce the acid will be more stronger than that of the phosphorus. Coming to the next strength, next to this one, third one. Third one, what is given is N2, N2O5, has greater strength than P4O10, having greater strength than AS4O10. This is having greater strength than SB4O6. This is exactly what we discussed in the previous discussion, previous slide. This is also correct. Option number 4, what is given? What is given is Pi3 greater than, I'm sorry, this less than Pi3 less than PBr3 less than PCl3 less than PF3. And what is given is this is the increasing order of bond angle. Okay, this is also wrong, it's incorrect, and option 2 is also incorrect. Reason: bond angle of trihalides of group 15 element increases with decrease in electronegativity on halo atom. X means what? Halo atom. Along with increase in size of halo atom. It's a very, 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 very important fact. In fact, I can give the magnitude of bond angle also for you. PF5 is actually less than PCl3. PF3, I'm sorry, PF3 less than PCl3 is less than PBr3, which is less than Pi3. In fact, the magnitude of bond angle is 98.5 degrees, and this will be 100 degrees. Sorry, when I write always degree, I remember the temperature. It's bond angle. PBr3 101.5 degrees. This is 102. What is the reason for this? When electronegativity decreases, electronegativity of halo atom decreases, bond pairs bond pairs remain more close to central atom, and hence bond pair repulsion increases, and therefore bond angle also increases. Okay, thank you.